Hi guys, if you are viewing my channel first time, please subscribe to my channel for more updates on machine learning. Today we are mainly discussing about on gradient descent boosting. It is one of the superior learning technique in our machine learning. By using superior learning technique, the prediction can be made. Gradient descent boosting always follows the boosting technique for training and also prediction. That's why we want to discuss the background of the ensemble techniques here. Here ensemble techniques are two types: bagging or bootstrapping aggregation, and second one is boosting. Bagging or bootstrapping aggregation is a parallel process. Boosting is a sequential process. And here we will see how the training and also prediction by using bagging or bootstrapping aggregation. Here, for example, I have taken one data set, 1,000 records. This 1,000 records, randomly 700 records I have taken for the original training data. This original training data I am dividing into the multiple data sets here in the step 1. Here data set 1 random 400 records I have taken from this original training data, that I am mentioning it as data set 1. Similar way 420 random records I have taken for the this data set 2 from this original training data. Similar way data set t minus 1, data set t. And the step 2, build multiple classifiers or regressor in the step 2. Here with respect to, I will use this data set and I will create my model, either classifier or regressor, based on our problem. For example, similar way classifier 2, regressor 2. Similar way classifier t minus 1, regressor t minus 1 with respect to this data. Similar way classifier t divided by or regressor t. Okay, here in the final we are combining all the results. For example, if my problem is classification problem, then I will apply all the classification models here. Okay, then I will combine all the results at the end. Okay, here for example, in case of classifier, I need to take the majority voting. For example, classifier 1 I got prediction as true. Similar way classifier 2 I got the prediction as true. Classifier t minus 1 also I got the prediction true. Classifier t I got the prediction as false. Okay, here highest voting was true. That's why I will try to predict using the here I am just combining which is having highest vote, that I am selecting as my prediction. This is my true is my prediction. Similar way in case of regression, just we in case of this regressor 1 I got the prediction as 10, regressor 2 I got prediction as 20. Similarly regressor t minus 1 I got 30, regressor t I got 40. Okay, here I need to add all the results and divide by 4. Just I am aggregating all the results, that I am mentioning it as my prediction. This is a way mainly the training and also prediction using the bagging or bootstrapping aggregation. Mainly random forest follows this technique. And here mainly we need to discuss on today boosting technique. Here previously we discussed on AdaBoost. Okay, that already you can see my previous videos. And right now we are discussing on second technique, gradient descent boosting. Next we have another technique also, XZ that we are discussing in the next sessions. Okay, here we'll understand how the boosting algorithm will work here. Okay, here I taken 10 records. I'm just passing to the first model. Okay, it was classified as only 3 records as blue and the other 2 blue records as red. Okay, these two are misclassified in the first iteration. Okay, that's why I'm going for the next iteration. I want to classify these two misclassified in the next iteration exactly. That's why I want to go to the another iteration. That's why I'm just targeting to these two records what are the misclassified in the first iteration. Just I'm targeting to these two. Then if I just calculate the prediction, again I got this misclassified. Okay, these three blue records classified as red. Okay, here again it was misclassified. Then I'm go further next iteration. Just I am these three misclassified records I am trying to classify in the next iteration exactly. That's why I'm drawing a line here to classify exactly all the blue records as blue. And here I see all other red records as blue here. These are misclassified in the third iteration. Okay, these three are weak learners. Okay, here these three are weak learners. Just I am combining all the weak learners into the strong learner at fourth iteration. Okay, just here we are just combining all the results to get the highest prediction power. Okay, here mainly we are using the ensemble techniques to get the highest prediction power than single models. For example, in case of linear regression or logistic regression or decision tree, okay, anywhere we are using we are using only one model for the training or prediction. But in case of ensemble technique, we are using multiple models for the training and also prediction to get the highest prediction power. That's why we are going for this ensemble techniques. Okay, we will discuss more on this gradient boosting today. And gradient boosting can be used for both classification and regression problems. Okay, today we are mainly discussing about on this regression problem today. That's why we will discuss in the next sheet how the regression will take one example, how we'll train and also how we'll predict. Okay, here in the second sheet we will see here, as we discussed here, always gradient descent follows the sequential process, right? Okay, similar way I'm just creating my decision trees sequentially. Okay, whatever the output of the first decision tree I'm giving to the second decision tree. Similar way, second decision tree output I'm giving to the third decision tree. Okay, this is a very sequential process. And in case of first iteration, I am just passing my original data. Okay, here x and y. X is my independent variables and y is my dependent variable. Okay, here just I am passing my all the data, whatever the records I am passing to the first decision tree, and I will get the output here h1. Okay, here I got the prediction. Now I am just passing to the next iteration. Here I am just passing my original independent data as it is. Okay, original independent data as it is, but dependent variable I am passing it as actual minus prediction error. I am passing to the next decision tree. Whatever the error I got in the first decision tree, I am passing it as target. Okay, target as error. Okay, similar way here it will try to again form a decision tree. It will try to predict. I got the h2. Okay, similar way here actually is y minus y h1. This is my actual minus prediction. Okay, again I am passing the error as a target in the third decision tree, but whatever the independent variable data is as it is. Okay, now I got the prediction as h3. Okay, just we'll understand first. In the first iteration I am passing original data set, what is my independent data, what is my dependent data. I will get the prediction. Okay, in the second decision tree onwards we need to pass the previous decision tree error. Here what is my actual minus h1, y minus h1 is my error. Just I am passing error as my target, my independent data as it is. Okay, just similar way I'm just trying to predict. Okay, similar way here in the third decision tree also I'm just passing the error from this decision tree 2. Okay, similar way here I'm just passing as target and my independent data as it is. Okay, similarly finally I will get the prediction as h3. Okay, here we will understand what are all the formulas in the gradient descent boosting. Okay, here loss function mainly here, our gradient descent boosting, how we are making our prediction and also training mainly loss function. Okay, here we want to reduce in each and every iteration, we want to reduce the loss of our model. Okay, that's why we are going for this gradient descent boosting. Okay, here this is my loss function equation, e equal to actual minus mean whole square divided by 2. This is my loss function, and here I am applying derivative of e divided by derivative of de by dh, my derivation of this loss function equal to actual minus h, actual minus mean multiply minus h. If I just apply the derivation to the left and right, then I got the equation like this: actual minus mean multiply minus 1. Okay, this is my gradient descent formula. This is h equal to h minus alpha. This is my learning rate multiply de by dh. That's why we applied the derivation in the above equation. Okay, this equation I am just replacing it here. Then finally my equation is h equal to h plus alpha. This minus and this minus I am just mentioning it as positive, minus multiply minus positive. H equal to h plus alpha actual minus mean. This is my final equation. Just I am simplifying it as for the multiple models. Just I am expanding my equation to new prediction. This is a model 1 prediction plus summation of learning rate multiply error. See here model 1 error. Similar from the model 2 onwards, we have to just calculate using the learning rate what is a model 1 error, plus similar way model 2 what is the learning rate, what is my error. Okay, this learning rate is always constant throughout the model. That's why this learning rate multiply model 1 error. Similar way learning rate multiply model 2 error. Similar way, model 3 learning rate multiply model 3 error. Okay, this is the way we are just doing the addition. Finally we'll get the new prediction. We'll just calculate how we'll try to train and also get the prediction by using one example. Here x1 and x2 my independent data, I have just three records, and here my actual data, this is my two independent variable, one dependent variable I am passing to the model 1. Here in the model 1 I got the prediction. Okay, prediction as a mean. Okay, here I am just calculating the mean of this complete three records. Just I am just summing all these three records divided by 3, then I will get the mean of this actual data. Okay, just I am mentioning it as my mean as prediction. Okay, similar way I am just applying all the means. Just this mean I am just copying to the all the prediction. Okay, if I just calculate the error from this, just I want to pass this error to the next model. That's why here I am just calculating the error is equal to actual minus prediction. Actual is 174 minus 173, this is my one is my error. Similar way, 176 minus 173 3, 169 minus 173, this minus 4. Okay, here I got the error from the first model one. Just this error I am passing to the next model as a target. Okay, in the next iteration this error will be reduced. For example, this is my h2. For example, my error was reduced to zero point 0.5. Okay, let us assume, for example, this my target I am passing it as this one will be reduced to zero point 0.5 in the second model, let us assume. Just then we can calculate what is the prediction of my model 2. Here just I am calculating the prediction for the model 2 using this formula. Here model 1 prediction is 173 plus what is my learning rate, I am using it as zero point 0.1. 173 multiply 173 plus zero point 0.1 multiply what is the error is zero point 0.5. Okay, then I can calculate the prediction from this h2. Okay, here I got the prediction as 173.05. See here, we are trying to whatever the my prediction I am trying to reach to the actual value. Okay, finally, if I go further iterations, finally I will try to reach this 173, 174 finally. For example, in the first iteration I got 173. In the second model prediction I got 173.05. Okay, I am trying to reach this actual value. Finally, if I go to the further iterations, for example, after 10th iteration, this actual and prediction will be matching. For example, for the model 3, model 4, model 10. Okay, in case of model 10, this actual and finally our prediction also will match. Okay, at that time we'll try to stop our this sequential repetition. Okay, until that much we will try to go further iterations, then finally we will end our tree. For example, if I go for example 100 or 200, then it might be overfitting. Okay, that's why we have to go only several iterations only, we should not go further. Okay, that's why we'll see the difference between the what is the AdaBoost and gradient boost here. Okay, in case of AdaBoost, we used to increase the weight what and all the misclassified objects. For example, in case of iteration 1, what and all the objects are misclassified, that I am trying to increase the weight, that I am passing to the next iteration. This is the way the AdaBoost will work. Here in case of gradient boost, we are optimizing the loss in each and every iteration. For example, here in every iteration, we are just reducing our loss function, our whatever the error we got from the previous model, we are just optimizing the error for each and every iteration. And in case of AdaBoost, stumps will be used. Stumps means one root node and two leaves. Okay, only the we are just restricting our tree to only one depth. Okay, here the our gradient boost, whatever the tree we can up to limit with 8 to 10 leaves. Okay, this much our decision tree can be increased in case of gradient boosting. But in case of ADA boost, only one root and two leaves. But in case of gradient boost, we can up to expand our tree up to 8 to 12 leaves. Okay, here we will understand how the gradient boost will work. For example, in case of first iteration, I don't know the intercept. For example, that's why I'm just mentioning it as my intercept is 0. Just I am drawing a one line here. Okay, just I'm calculating the what is the residuals of our model. Okay, I got the maximum error. If I calculate the accuracy for the prediction of this linear regression, just I'm explaining here how the gradient descent will work, mainly how here the prediction and also where we need to stop. Okay, in case of first iteration, just I am considering it as my intercept as 0, and just I am calculating my residuals. I got the maximum. Similar way, I just drawn a line at, for example, let us assume here 1 intercept 1 means I got the less residuals. That's why here this as my best fit line. Okay, similar way, if I go further, my intercept I'm just increasing to 2. Okay, at this time I got the highest again highest residuals. That's why we just want to go only little bit iterations. For example, let us assume we have to go until unless where we got the less error and more prediction. At that time we need to stop our iterations. For example, 10th iteration I got the highest prediction power and also less residuals. Okay, then we have to stop our boosting until unless only 10th iteration. We should not go further. Okay, that's why we are just drawing our function like this. Then we can just repeat our iteration. For example, I'm just repeating first iteration to 20th iteration. For example, 10th iteration I got the highest prediction. Then we'll stop the our iterations only until unless when we got the highest prediction. Okay, this is a way our gradient descent boosting will work here. Okay, then we will understand a little bit about the code here by using the Jupyter Lab. Just I am exported whatever the code from the Jupyter Lab here. Just I'm explaining using the HTML file. Here, this is a gradient regression. Here we'll see practically. Here I am just importing my libraries. Import pandas as pd. This is my pandas. If I want to just work on my excel sheets, then we need this pandas. That's why I'm just import pandas as pd is my alias name. Here importing the data set. This is my object equal to pd is my alias of pandas. Pd dot read csv is a method to access my Excel sheet. Okay, salary.csv I'm just accessing it here, and object dot head it will display the first 5 records. Okay, let us see the what is the data set we have. Here I have 1 years of experience is a one column and another column is the salary. This is my independent variable. This is my dependent variable. This is my x. This is my y. Okay, here I am just dividing into the 4 parts. First is this is my training set. Training set is zero point 0.5. Just I am mentioning, and also test set also zero point 0.5. That's why this 30 records I am dividing into the 15 and 15. 15 for the train and 15 for the test. Okay, just similar way I just divided as per my understanding. Okay, here I am just dividing into the 4 parts. Here x I am just dividing into the this is my x this is my train data. That's why I'm mentioning it as x train if it is my x column. Similar way, this is my test data. If it is x column, just I'm mentioning x test. Similar way, if it is y column, if it is my train data, I'm just mentioning y train. Similar way, y test. Okay, first we need to split our data set into these 4 parts. Just we need to pass, if I want to train our model, just we need to pass x train and y train to train our model. Next, after that, next we need to predict. Okay, next step, here I am just passing x test, then I will get the y prediction in the second step. If I want to get the prediction, just I need to pass the x test, then I will get the y prediction. Then we can calculate the accuracy of our model by using this x test and y prediction. Then similar way we will understand here. Okay, just initially I just accessed my data set, whatever the data set here I am just explained, right? Similar way, here 1.1, 1.3, just I am displayed as here first 5 records. Then just I am confirming whether my data set correctly I am accessing or not by using this head command. Okay, next after the data pre-processing, here I am just processing my data. Here x I am mentioning it as my years of experience, this complete column, and y I am mentioning it as salary. This y is my salary. Just I am printing my data here, print x and print y. Years of experience is my x and salary is my y. Similar way I just printed. Now as we discussed here, similar way I am just splitting my data set into the 4 parts by using this from scalar model selection import train test split. This is a method to split our data into the 4 parts. What is my x? This is my years of years of experience is my x. Similar way, salary is my y. Similar way, I just passing this x and y. Here I am mentioning what is my train and test size. Train size I am mentioning that it has zero point 0.5. Similar way, test size will be remaining, means zero point 0.5. Okay, next random state, always we should initialize with something, otherwise we'll get the always different prediction. In each and every time execution we'll get different prediction. To get the constant prediction, this random state should be with initialize with something. Okay, here I am just dividing into the multiple parts, x train and x test, y train and y test. Similarly as we discussed here, I'm just dividing into the four parts. Okay, next here I want to train our model. Here I'm just using the gradient descent regressor here from sklearn ensemble. This is my ensemble method as we discussed in the initial introduction. Here this is my object. I'm just accessing my gradient boost regressor class, and this is my object dot fit. I'm passing x train and y train as we discussed here. Just I'm passing x train and y train to train our model. Just I'm passing these two to train our model. Here the training is done. Here the mainly we are using this loss function for our each and every iteration. We are just calculating the loss function, and we are trying to reduce our loss function in each and every iteration. That's why here these are mainly parameter. These are learning rate as we discussed in the initial calculation, and also the MSC mean square error we are calculating in each and every iteration, and based on that we are going further iterations, and remaining all other hyperparameters are with respect to the decision tree. Okay, here initially 100 decision trees will be used. If you want, we can just mention how many iterations we want to build our gradient boosting algorithm. Okay, here we can adjust our hyperparameters by passing from here. Okay, here my training is done. Similarly, I am using my object dot predict. Just I am passing x test, then I will get the y prediction. Okay, similar way here I am just passing the x test, then I will get the y prediction. Then we can calculate what is the accuracy, what is my actual data, what is my prediction data. Okay, here we have some metrics we need to calculate. What is the r square score, and RMSC and MSC. These are the regression scores. Just we need to calculate by using sklearn imports. Okay, from sklearn matrix import, I'm just importing mean square error function, and also r square score. Here I am just mean square error, I am passing y test and y prediction. What is my actual data and prediction data? Prediction data I got from this x test. Okay, here my model testing is done, and after that we need to predict. Here I got the MSC from this method, and here r square score. From this method I'm just passing y test and y prediction, then I will get the r square score. Okay, here to get the RMSE, just I need to square root. This is a mathematical function from math import sqrt. Here just I am passing MSC, just I will get the RMSE here. Here just I am replacing, just I am trying to display all the results here. This is my MSC. I am just displaying it here, 72108,256. Similar way, r square score, just I am displaying it here, 0.91. Here I got the efficiency of our model is 0.91, means 91% of efficiency. Okay, here RMSE, just I got it from here, just I am displaying it here, 8491. Okay, here I am just by using this metrics we can assume our whatever our model is efficient or not. Okay, this is a way we can try to build our model by using this Jupyter Lab. Thank you friends, thank you for watching. If you like the video, please like, share and subscribe. Thank you.